Introduction to exothermic and endothermic reactions. Chemical reactions can be categorized based on how they interact with energy. Exothermic and endothermic reactions are the two main types, differing in whether energy is released or absorbed. Understanding these reactions is crucial in fields like chemistry, biology, and engineering. What happens in exothermic reactions? Exothermic reactions release energy into their surroundings, typically in the form of heat or light. This release occurs because the total energy required to break the bonds in the reactants is less than the energy released during bond formation in the products. Examples of exothermic reactions. Common examples include combustion, where fuels like wood or gasoline release heat and light when burned. Another example is respiration, where cells break down glucose to release energy. These reactions all involve the release of energy to the surroundings. What happens in endothermic reactions? Endothermic reactions, in contrast, absorb energy from their surroundings. This absorption occurs because the energy needed to break bonds in the reactants is greater than the energy released when new bonds form. This often results in a decrease in surrounding temperature. Examples of endothermic reactions. Photosynthesis is a key example of an endothermic reaction, where plants absorb sunlight to convert carbon dioxide and water into glucose. Other examples include the melting of ice and the evaporation of water, both of which require heat to proceed. How energy flows in exothermic reactions. In exothermic reactions, energy flows out of the system, making the surroundings warmer. The reactants have higher energy than the products, and this excess energy is released during the reaction. This is why combustion reactions, like burning wood, feel hot to the touch. How energy flows in endothermic reactions. Endothermic reactions require energy to be absorbed, usually as heat, to break the bonds of reactants. The products of these reactions have higher energy than the reactants. This is why processes like ice melting or water evaporating feel cool to the surroundings. Differences between exothermic and endothermic reactions. The key difference is energy flow. Exothermic reactions release energy, making the surroundings warmer, while endothermic reactions absorb energy, cooling the surroundings. The balance of energy required versus energy released determines whether a reaction is exothermic or endothermic. Conclusion. The significance of both reactions. Both exothermic and endothermic reactions are essential in nature and technology. Exothermic reactions help provide energy in processes like heating and combustion, while endothermic reactions are vital for energy absorption in processes like photosynthesis and cooling systems. Understanding these reactions is fundamental in science.